To overcome the challenges of energy scarcity and climate change, renewable energies have become an attractive option because they deliver a significant reduction in net carbon emissions. In this short video, we will compare the life cycle assessment of electricity generation through the combustion of chicken manure and rapeseed oil. The following assumptions were made. Our model starts a collection. Therefore, any electricity consumption or GHG emissions from chicken raising is not taken into account. 1 ton of chicken manure at 50% dry weight loaded onto the loader and transported over 150 kilometers from the farm village to the combustion facility. In storage, a draft fan is used for ventilation and odor containment. Assuming 24 hours of storage, the energy used for ventilation is 12.6 kilowatt hours. Assuming the electricity comes from burning natural gas, emission of CO2 comes to 7 kilograms, based on US Energy Information Administration's emission rate. At this point, manure goes through a drying process before being sent to the combustion chamber. The manure is dried from 50% to 60% dry weight. The weight is reduced from 1 ton to 833 kilograms due to evaporation. The industrial furnace runs on natural gas and uses 340 megajoules of heat to dry 1 ton of manure. In this process, 1 kilogram of methane is emitted. At this stage, the manure's energy content is 3 kilowatt hours per kilogram. The combustion generates 1.26 kilowatt hours per kilogram at 42% conversion efficiency. The rest of the energy is dissipated in the form of waste heat. Assuming the organic chicken manure is 50% and all the carbon content is converted into CO2 during combustion, 333 kilograms of biogenic CO2 are emitted in the burning process. 4% losses occur due to transformation and transportation. This means that 1.21 kilowatt hours per kilogram are actually delivered to the consumers. So by combusting 1 ton of chicken manure, we can power 103 persons' households in the Netherlands. Looking at the following table, we see that rapeseed generates roughly 3 times more electricity than chicken manure for the same weight, respectively 3.72 kilowatt hours per kilogram and 1.27 kilowatt hours per kilogram. Rapeseed efficiency is better than chicken manure because it is co-fired with natural gas and heavy oil, among other factors. The global warming potential for chicken manure is 85 times that of rapeseed. This is due to CO2 emissions from natural gas combustion in the industrial furnace and electricity for storage. Also, unlike rapeseed, methane is emitted during manure transportation. The global warming potential of methane is 21 times that of CO2, so this amplifies the total global warming potential of chicken manure combustion. We also added dinitrogen oxide emissions from manure combustion based on literature research. Dinitrogen oxide has a global warming potential 310 times larger than CO2. This explains the difference in global warming potential from chicken manure compared to rapeseed. As a side note, biogenic CO2 emissions resulting from chicken's diet were not incorporated into the global warming potential. However, biogenic CO2 does contribute to global CO2 concentrations, so to present a more complete picture of the carbon cycle, this process could be included into the system. For this reason, carbon sequestration to minimize CO2 emissions could be implemented. We came up with some suggestions to lower the environmental impact of electricity production from chicken manure. First, in order to cut down emissions, we can use the waste heat from combustion in the drying process. In this way, we can reduce natural gas consumption, CO2 emissions, and furnace operation costs. Secondly, the combustion process should consider co-firing with wood chips, so to increase efficiency. Studies recommend a 30% wood chips with 70% chicken litter mix. Hence, the collection for farmers will be easier since they could include sawdust from stables. Finally, we could also generate biogas through anaerobic digestion prior combustion. The methane generated can then be used for electricity generation. Burning methane is much more efficient than chicken manure, and it can be used as a biofuel in other applications.